For more than 40 years, Beech Aircraft Corporation has been recognized worldwide as the producer of the finest private and military aircraft available. We at Beech are proud of that reputation. But at the same time, we're equally proud of the company's contribution in another area. The production of realistic target systems, sharpen the skills of defensive weapons teams. Such targets must be capable of realistically simulating all the characteristics of attacking aircraft. Since the mid-1950s, Beech has continuously produced such targets. Targets utilized by the United States military services and military services of other nations. Among them, United Kingdom, Spain, West Germany, Switzerland, South Korea, and the Republic of China. Beechcraft missile targets over a range of performance unequaled by any other operational target in the world. Range of Beech targets encompasses an operational envelope that includes altitudes from sea level from 100,000 feet and velocities from low subsonic to high supersonic. Beech also maintains crews of trained flight service technicians who can provide customers with the expertise required to obtain the full range of effective features available in the operation of Beech targets. The MQM107A is produced by Beech Aircraft Corporation, one of the world's leading manufacturers of general aviation and special use military aircraft, with component sub-assembly manufacturing and testing at the Wichita, Kansas Beechcraft facility and at the Boulder, Colorado Beechcraft plant. Simplistic design and modularity of construction are primary methods employed to ensure that the MQM107A is cost-effective in the area of refurbishment as well as initial fabrication. Systems are contained in seven major airframe sections. The aircraft's nose section is a modified ogive shape, constituting the forward fuselage assembly. The forward of the three units composing the nose cone is constructed from a spun aluminum sheet, which is bonded to a formed sheet metal bulkhead filled with shock cushioning foam. After the nose cone is a rolled and welded spun aluminum shell, into which is riveted a formed sheet metal bulkhead, which serves to mount the nose cone itself and provides support to the forward end of the electronics equipment shell. The payload compartment is a rolled and welded aluminum shell containing the riveted sheet metal frame to which the electronic shell and compartment are mounted. After the nose section, the fuel tankage section, which is the greater part of the fuselage, consists of an all-aluminum welded structure with a skin consisting of a rolled aluminum cylinder with a butt welded seam. In the interior of the cylinder are five domes, which enclose three fuel tanks, each with a capacity of about 22 gallons, and one tank which contains oil to be used for smoke generation by the target. Three machined frames are also positioned and resistance welded with the cylinder. Provide points of attachment for an external hoist beam for lifting the aircraft. A fourth machine frame is riveted to the cylindrical section at the aft end. The placement of the welded-in domes and frames, and the riveted-in frame with a skin, give this section load-carrying structural continuity, or loading stress imposed by the engine, recovery system, and launch JATO motor. Two of the welded-in frames used for installation of fittings, which will mate with military standard air-launched pylons. The aircraft's aft section is a conventional semi-monocoque structure made up of formed aluminum sheet metal skins and riveted in place frames. These frames provide rigid points, which may be attached to the empennage, the aft hangers for the mounting of the JATO, and supports for the parachute container. Doors in this section provide access to the components of the fuel system and the recovery parachute attach fitting. The wing is comprised of three sections. The center section is constituted of an aluminum honeycomb structure with a foam-filled leading edge, backed by a riveted sheet metal trailing edge. Rigid areas constructed of higher density combined with doublers are situated in the honeycomb panel, provide for attachment of the wing to the fuselage and attachment of tow target launchers to the wing. Outboard wing panels are structured in a fashion similar to the center section. Wingtips are molded of high-density foam and may be removed to permit mounting of wingtip pods. Outboard panels are joined to the center section by panhead screws and are interchangeable. Ailerons are composed of one-piece formed aluminum skins bonded in torque tubes and trailing edge members. The skins are stabilized with foamed-in-place cores. The empennage consists of the vertical stabilizer and the horizontal stabilizer upon which the elevator is mounted. These parts are constructed in the same way as are the wings. Since the horizontal stabilizer is designed with a trailing edge sweep, a universal joint is used to identical elevator halves together. High-density foam composes vertical and horizontal stabilizer tips. The wing fairings are a combination of formed polycarbonate and aluminum sheet. The empennage fairing is formed of polycarbonate sheet. The propulsion system for the Model 1089 is the Model J402CA-700 turbojet engine. Essentially, a longer life version of the J402 harpoon engine. The engine, weighing only 113 pounds and less than 30 inches long, can develop a maximum continuous thrust of 602 pounds during static firings at sea level. Delivery of 640 pounds thrust during sea level static can be maintained for non-continuous firings. To ensure quick assembly and checkout of the Model 1089 is shipped with major components, including pre-assembled, nose section, outer wing panels, vertical stabilizer, and parachute assembly are mated to the target after arrival at the destination. All components for an individual target are packaged and kept together. Pre-flight and pre-launch checks of the aircraft is accomplished with the use of ground support equipment designed to thoroughly check critical systems before each launch. It is a simplicity yet ruggedness of construction that increases the cost effectiveness of the Model 1089. The MQM107A is extremely stable in launch operations, reaching a velocity of 230 knots at JATO burn. This is about 100 knots faster than minimum flying speed. Due to the stability of the MQM107, this fixed launch may be used to launch the target into up to 50 knots, or a tailwind of 20 knots, or crosswinds up to 10 knots. Rates of climb exceeding 10,000 feet per minute have been demonstrated. The aircraft has been flown to altitudes of 40,000 wingtip pods, and also with one radar target and a second target towed on a 5,000-foot line. A variety of mission plans may be used to take advantage of the MQM107A's myriad capabilities. For challenging the basic Hawk system, radar tows with 5,000 feet of tow line may be utilized. At 15,000 feet, the vehicle exhibits an endurance of 87 minutes, nearly an hour and a half, at a speed of 250 knots, or 53 minutes at 350 knots. Modified radar tows with 8,000 feet can be used for training improved Hawk with flights at 250 knots and 35,000 feet, 117 minutes of endurance, 86 minutes at 300 knots. For training Vulcan, an endurance of 78 minutes at 250 knots at 10,000 feet, towing a 2x12 gunnery banner, or 47 minutes at 300 knots. The VSTT provides excellent training Red Eye and Chaparral crews, utilizing Hayes TA-GA1R81 infrared augmentation. A smoke augmentation which provides a dense white smoke by injecting oil into the jet exhaust just after the engine is important in providing other unusual controlled weapons assistance for visual acquisition of the target. The target contains 4.4 gallons of white oil, providing 4 minutes of continuous smoke operation. Although the system is generally used to produce short pulses of smoke. The aircraft's endurance allows multiple presentations to missiles while operating at variable speeds in a single flight. As many as 8 presentations with tow targets, 12 presentations with a basic missile may be achieved. The rugged design of the MQM107A has been tested for maneuvering through over 5 Gs with no fail. This allows exceptional use as an evasive to further challenge training crews. The target may be remotely controlled when the target is out of sight. An entirely transport tracking, control, and telemetry system ground can be combined with airborne to provide a completely integrated control system. This system provides tracking to a distance of 115 nautical miles with accuracy to 10 yards. The recovery system of the Model 1089 has proved to provide a safe recovery of the MQM107 throughout its operational interval. A two-stage parachute system utilizes a drogue chute may be deployed at any speed up to 500 knots, generating a maximum load of 13 Gs at 5,000 feet on a standard day. 8 seconds after drogue chute, allowing time for the vehicle to the main chute deploys if the target is below a pressure altitude of 10,000 feet. Above 10,000 feet, barometric pressure switch deployment of the main chute unless manually overridden, thus preventing lengthy descents from higher altitudes. Initial ground impact is absorbed by the expendable foam-filled nose which crushes on impact. To prevent dragging of the target after ground contact, a mercury fires a parachute release device when the target topples and reaches a tail-high 15-degree angle with the ground. Except for the expendable nose damage is generally restricted to small dents and scratch paint. The recovery may be concluded with a helicopter or by ground unit. In preparation for the next flight, the nose is removed. Engine fairings are removed, allowing ready access to the engine, which is along with the airframe. Any damaged parts are replaced. Using the pre-flight guidance and control test console and visual inspection, the guidance and control systems are thoroughly and quickly checked. The parachutes are repacked and installed. The aircraft is fueled with JP4 jet fuel and smoke oil and placed in ready storage for flight. Normal turnaround time with a team of 5 technicians is only 3 hours. The MQM107A may be used in over-water operations as well as over land. A variety of basic design provisions for water recovery were made in the MQM107A at the factory. The economy of these designed-in provisions makes it feasible for their inclusion in every vehicle. These features include application of corrosion protection to aluminum and steel parts, use of waterproof electrical connectors, sealed actuators, gyroscopes, amplifiers, fuel system components, and sealed command components. Sealing the forward fuselage compartment containing most of the airborne systems components is an additional precaution. Buoyancy in the aircraft is provided by the fuel tanks, honeycomb sandwich construction of aerodynamic surfaces, foam-filled aerodynamic control surfaces, aerodynamic wing and tail leading edges, wing tips, and nose cone. Further buoyancy is added by sealing the equipment and optional equipment bays in the forward fuselage. Requirements stipulate that the vehicle with a 50% fuel load remain afloat in seawater for a minimum of 1 hour. The MQM107A meets these requirements. After the VSTT impacts the water, the main parachute riser is automatically released. The air vehicle is designed for quick and simple decontamination of all components affected by submersion in either salt or fresh water. Installation of television camera and transmitting equipment, or film cameras, make the MQM107A an ideal reconnaissance tool. The MQM107A can thus be used to report on behind-the-lines enemy activities, explore uncharted terrain, conduct a perimeter patrol, or collect weather data. without the endangering of personnel. A typical reconnaissance flight involving internal payloads of up to 100 pounds could cover distances as far as 380 nautical miles away from friendly territory. The MQM107A is an excellent vehicle for defense suppression and penetration missions. The aircraft may be mounted with gun pods, guided or unguided missiles, frag bombs and incendiaries, or other ordnance to be delivered or may be used to deliver flares or leaflets. Typical flight profiles for defense suppression and penetration missions carrying up to 500 pounds of external stores show that the MQM107A may operate as far from friendly territory as 195 nautical miles. The target may be used for electronic countermeasure missions, such as dispensing chaff to provide area jamming for attack aircraft or missiles following behind. The MQM107A may be equipped with infrared and radio frequency augmentation devices to simulate warplanes as decoys to draw enemy fire in diversionary missions. The target has everything a VSTT should have. Performance to survive the enemy threat in a hostile environment. Altitude capability to 40,000 feet. Maximum speed in excess of Mach 0.85 at all altitudes. Maneuverability in excess of 5 Gs. Endurance of 3.5 hours. The MQM107A possesses the versatility to perform a variety of missions calling for different internal and external payloads, and has the mobility to travel with frontline troops. Is easily serviced and launched by a small crew from ground zero length launchers. The 107A is highly controllable from many different sources with data link communication from the ground, in forward positions, or remotely from rear positions through satellites or droned aircraft. It is inexpensive, uncomplicated in design and construction, utilizing a low-cost, highly dependable engine, and extremely rugged in design and construction. The low cost of the aircraft makes it eminently expendable. Or, utilizing a highly efficient recovery system makes the MQM107A even more cost-effective with repeated recoveries and multiple missions per unit. The MQM107A, VSTT, like any other Beech craft, built to be the best. This has been a presentation of the Beech Aircraft Corporation.